So first thing on the agenda is introductions. I don't think I see any new faces here today, so we'll move on to release planning and updates.
I can speak for the implementation team. Sorry. Oh, I'm sorry, Dan. Okay, I'll be fast. Yesterday, we shipped a patch of the lifecycle to fix a bug where we were retrying to pull image manifests even if the first request was successful. So that added a total of 300 milliseconds per manifest and tripled the number of pulls, which is not great, but we patched that. And we continue working on lifecycle 012.
Awesome.
So,
platform, sorry, go ahead.
okay. Yeah, so from the platform side, we pushed our release to May 26th because we recently cut an intermediate patch and have quite a bit left we'd like to get done for pack 019.0. So, but it'll happen.
And any updates on the distribution side or other subteams? Going once, going twice. All right, we'll move on to our RFC review. As a reminder, if there are RFCs you want to talk about, I'll say ahead of time this time, please put them on the agenda so that we don't go over them in the review. So first thing on the list is from Sam. Actually, I think most of these are from Sam, about build right flag for layers. And there was some discussion about this last time. I forget where we landed. It's like, do we need a whole different type of layer? Something like that. Where are we at with this one? Do we want to talk about it this week?
I think there was, you had some proposal at the end of that discussion, which was an alternative to this. Like you were saying we should first fix this issue where it can like modify things and then have a separate RFC to figure out how to share layers between different build packs. The only thing that worries me is that like this is currently a useful feature that I do use. So if we just remove this entirely without adding something in at the same time, that's the only reason I wanted this as an atomic change as opposed to two different RFCs. But yeah.
I think other people push back with the same feedback also. I'm not strongly opinionated. I was just trying to see if we could agree on, maybe really what we do is agree that we should remove the one part and then in the atomic RFC also come up with a solution to it too. Do we want to talk about this or like, do you want to put it on the agenda for this week or?
Yeah, sure.
Cool. Seems like there's decisions to be made. Add bomb to layer content metadata. This is an FCP. FCP closing. Yeah, it says 7 days ago, so it's probably today. And the shepherd is Emily.
Roger. I will merge it.
Awesome.
Is it possible to use the new issue creation thing yet, or do we still have to do this one the old-fashioned way?
I think someone has to implement the issue creation thing, which hasn't been implemented. Sorry.
No worries.
Cool. So it seems like that's being taken care of. This one is blocked on allow setting default command line arguments can be overridden by the user. This is blacked on. I think Emily said you were going to open an alternative.
Yes.
Any updates this week or?
No.
No worries. Maybe sync up with Sam if we need to move this one forward more quickly. Next one is disambiguate layer metadata from app metadata. This one,
I think the main like blocker with this may be all of the edge cases that might arise and whether we want to handle them or how we want to handle them.
this is about the structure. Is that right?
Yeah.
I think the open question is, and I left a big comment about this, what to do with different API combos, like two build packs with two different build pack APIs, a platform API, like, because this new structure is involving changing both build pack and platform APIs. So how do we want to handle all the combinations? I think that's something we have to do because we can't get into a state where if one person updates their build pack, everything fails if everyone else hasn't. And I don't think we're going to get into a state where if you update the build pack, you can't run on older platforms. The solution is a little ugly when you're dealing with the compatibility, but I think that's just what you have to do.
Why isn't the new thing backwards compatible with the old thing? Why can't we just move everything into the new directory and then pass the different paths onto things in the old build pack API because the paths aren't in the spec?
You can make configure, like let's say I'm a build pack and I upgrade to the new API and I'm expecting an environment variable that's layers dir and an environment variable that's config dir. If you're using the old platform API, those have to be the same directory.
Oh, can we just support the old file paths for the configuration? And just drop that support when you bump your API version high enough or something?
I don't know exactly what you mean.
So like the problem is that the configuration is moved out of, we should probably put this in the agenda, but I'll just finish my,
Yeah.
The problem is the configuration is moved out of these build pack directories, right? Into this config directory, but can we just continue to support the old locations?
For old build packs, we can. Yes, that's what's being proposed here.
Maybe I just misunderstood.
Let's just put it on the agenda because it's complicated.
Next thing is mine guidelines for accepting component level contributions. This is an FCP 7 days ago. Terrence.
Closes. Oh, is this closed today?
So
Yeah. I don't think I need to do anything before this meeting, right? Just waiting for it to close.
Yep, sounds good.
For issues on this, do we put this under community? Like it should probably not just live in the RFC, right? Repo.
So I should copy these proposed guidelines into the community repo.
I think so.
Like a PDF.
Yeah. Yeah, I can open.
Issue
Yeah,
for
yeah, I can create an issue for it. But yeah, I think community is probably the right repo.
For community repo language or SC to PR and or
Yeah, I can create an issue that I'll assign you to do.
All right, and that covers our RFC review. Let's jump into the agenda. first thing is, how was KubeCon? What were common questions and what are your perspectives?
It's really not much deeper than that. We're all curious. How did you find the outside world?
I stayed very much inside during KubeCon. European time zones plus American time zones were pretty rough, but I thought the turnout went really well. I think on it was Tuesday, Wednesday, right? So for the ops hours, they were at I think 2 a.m. Central for both times. I think Sam said we had 160 or one something on the first day. I think we had like 150 or something on the second day for ops hours. Yeah.
It was up into the 170s at one point. And a lot of engagement, a lot of questions. Like, I don't think we answered all the questions, which is kind of a good thing. We just didn't have time to get through them all.
I was there for the second day and there was definitely a lot of stuff around, how it compares to other build tools, which I think is common. So I think we're getting a lot of people who are very new to Buildpacks or maybe hearing about Buildpacks for the first time. And then a lot other questions that I remember were around like CI/CD integration as well, which has been common from the talks that I've done at other KubeCons for intro talks. I think we've seen that as well. So I don't think we got any like fairly advanced questions, if I recall.
We had similar attendance for the talk Jesse and I gave. I don't know, Jesse, do you remember how many? It was like 100 and
I think it was like 150, something like that. Yeah, pretty good turnout.
got some good questions, but maybe not as many, or we were definitely able to answer most of them. My mic didn't work at the end, and I think we still got to everything pretty much. Jesse took a lot of them.
Yeah, I was definitely pleasantly surprised by the office hours, maybe even the format, right? We did a very quick overview of Buildpacks, but I think the fact that it was like very like open floor for conversations, and I think that was more or less the expectation, did kind of allow people to really ask questions, right? And have a informal conversation. So that was really cool.
How did people know about Buildpacks before the event? What was your gather? Was it they just found out about it that day, or just curious?
Yeah,
I don't think so.
If
I
you
think
could tell,
most
sorry.
people had, I mean, the only bit of data is I think most people that were asking questions had tried it or, looked into it. So that would indicate to me that they had known about it before the event, but that's just kind of anecdotal.
I think I probably would disagree a little bit with Joe. I think there was definitely those people, but I definitely felt like there was also people who just had no clue and were looking at it for the first time for some of the questions we got, for sure. Yeah, I mean, just hypothesizing to answer your question, Anthony, I think maybe we got into incubation. So maybe we get more marketing kind of in that, and we're on the schedule, on the maintainer track, and they're like, never heard of this thing before. What is it? I guess we didn't actually ask questions of the audience. We were really just on the receiving end of answering questions. So honestly, that'd be I would love to know the answer to that question, to be quite honest.
I think part of it is we're the only CNCF for like kind of high profile independent project that tackles container builds, right? Like there's some small things like, Conoco or, Jib that are, either Docker files or niche language specific things, but it's not like we're sitting among many other alternatives for solving the problem we're solving. And so if people come to KubeCon and are wondering about building containers, right, just kind of one set of talks there, as far as CNCF projects go.
Yeah, and that's probably where a lot of the kind of interest in how it compares to other build tools is coming from, right? Like, don't know a lot about Buildpacks probably, and trying to see how it compares to things you maybe are more familiar with.
discussed this during the learning team meeting, and we created some issues for like, well, since a lot of these were newcomers, they had some issues with documentation or like again FAQs. So we tried to create uh, some tasks for handling that on the documentation side.
I'll keep it. That was great for me. Thanks. That was maybe how I'll attend next year. Who knows? Y'all can move on.
Well, at least NA is coming up in the fall, and that will be probably easier time zone wise for you to hit there, Anthony. I will say, I guess as a closing comment, I think we were kind of not super excited about the office hours given our kind of experience from NA, and I was really similar to Javier, like really pleasantly surprised with just it was valuable and kind of versus I felt like for NA, like I felt bad assigning people shifts because it felt like you were just twiddling your thumbs during kind of how they did it last year. So it's definitely a market improvement from our experiences from the North America one, I think.
Yeah, and on a personal level, just funny story, I had a off by 1 error in my time zone calculations. So I like literally woke up right when it started. So I had to like rush to the first one. And so I was very off step on that one. But yeah, that's what we got.
Awesome. Well, we have quite a few things on the list, so I'll move along. Meta build packs and lifecycle extensions.
Yeah, I put these items in the reverse order from the last meeting so that we could talk about some of the other things. This was something that I brought up at the very end of last meeting, which was around so we've talked about possibly deprecating profile D. So typically when you have like some new RFCs for changes to life cycle or like something that add a common functionality across build packs, could we provide hooks or plugins into the life cycle where like people at the appropriate level of abstraction can plug in specific code that can act on the build packs rather than the application uh, to modify the output. So, for example, you could have like this meta build pack that rather than looking at the appter, looks at each of the build packs layer directory and then does some modification after the build process or during the launch time to like add these extensions so you could share common functionality across different build packs or possibly prototype RFCs before committing them to the like official API if we just want to experiment with something and don't want to commit like to supporting it in the longer run.
This be build packs that run on top of the output of other build packs after they ran. And these meta build packs are specified by the operator and they modify the layers directories of each of the build packs that ran. I just want to make sure totally have it.
Yeah. And possibly like some hooks during the, so that's why I have two parts there. One is meta build packs and one is like lifecycle extension. So the other part is like having some hooks during the launch time, which could be triggered to set up some other things before the application is launched. So those were like the two possible things I could think of.
Something like a operator specified execd, where the same operator that can create hooks that run after every build pack on all the build packs layers, they could contribute something that ends up in that final image, like kind of like a dot profile in the app directory, but not in the app directory. It's set, for all things on the platform or something like that, and thus end up with the image.
I understand the first case. The second one just sounds like a build pack though. Like you would just write a build pack that contributes an exec key, right? Like, is there anything that a life cycle, that a hook at build time that wouldn't be sufficient to meet the case where you need it at runtime?
I guess if you wanted to modify, I mean, I say hooks, but like if you wanted to modify some launcher behavior, which is not exposed to the Buildpack API. Again, this is completely hypothetical. I haven't thought of a lot of cases on the other side, like the lifecycle extension side, but I just thought it might be useful to prototype things. The first one, the clear use cases for that are like something like Profile D, or having like just reducing duplication across different build packs when you want to offer some common functionality to each of them. So as opposed to each of them using a library and like executing the same code, you have this one thing that can like modify all of them. And
I understand the use case. I guess what I would get worried about is API versions. Like, would this meta build pack need to describe, would it have an API version? Would it need to list all the build pack APIs for the types of build packs whose output it could modify? Like, I don't want to create too, I see why it's powerful, but I worry that sometimes our system of dependencies and compatibilities gets very complex. And this would add to that complexity.
Kind of a similar note, but maybe more philosophically or thinking about the design. I worry about a build pack writing a layer, and it thinks I'm creating this read-only, quote unquote, layer for the Node.js runtime, for Ruby, for Python, or whatever, and then something else that's a sanctioned part of the build process actually has the ability to change all that stuff and violate the assumptions that build pack might make, including code that the build pack created that intends to access files that it thought couldn't change and writable. So to me, I worry it's a little bit of a violation of that kind of like principle of everything is kind of like software that's being installed, into locations that are, controlled by the thing installing it.
And like, could we solve this instead with, more tooling for build pack authors, like helpers in libcnd, or a library of bash utilities for bash build pack authors to do some of these common things?
I guess you probably have a very specific use case in Bloomberg, and I assume this is like a very much probably a company level kind of lever that would get pulled. Like I can imagine maybe even like the Cigna case of like, this is just the security check thing that happens at the end across all layers or something along those lines. Is that kind of what you're thinking of for these kind of meta build packs?
yeah, I guess like if you have a family of build packs that all sort of share the same thing, I guess one way you could do it is obviously like provide some like library or extension that can be used, but that the issue with that is all the build packs have to be written in the same language, or you need equivalent implementations of that library code for each of the languages you're writing your build packs in. So if you have a bash build pack and if you have a build pack written in bash, you have one written in Go and one written in Python, you now suddenly have to write the same plugin for all three of them. That was the main issue. Like, and then if these have slight differences, and then like now this series of modifications that you expected to make are slightly different.
You talk about your use case a little bit more, or like, I think it's going to be really hard to, like, I think I get, you care about operator control here, right? It's like, you want to use different build packs from different people. You don't want them to have to modify their build pack. You want operator to be able to say, here's a function I'm going to apply to what each build pack has done at the end. Like, I buy that that is very valid use case, but it's hard to think more abstractly about how to solve that problem without understanding a little bit more about what you're trying to do. Is that something you can share?
Let's see. So one example could be like verifying the bomb in some way, or like for each of the build packs, figuring out if what they've contributed to is correct, or modifying the bomb to add some additional metadata, or like setting up some environment variables for each of the like build packs based on their contents.
I think all of that could be done with another build pack, which is an operator controlled thing. You can override environment variables. You mentioned reading layers, but I didn't hear anything in there that was writing into layers.
Yeah, so all of those could be done by a build pack. I agree. The issue was I have to now find a way to read all of the previous build packs through this last build pack.
In the cases where you want to read the data, though, and not write to it or change the process, could that be a tool that analyzes the image after it's already built?
I guess I want it to be part of the build process so that it ends up in the final labels and it's like one build process, whereas now you have two separate build processes, one that builds the image, then the second one that modifies some labels and things, and that creates a new image digest. So I wanted to avoid that for it to be an atomic process. And the other thing was, like, if I want to set some environment variables or something like that for based on each of the build packs layers, or contribute, let's say, some exec-d scripts based on each of the layers, then that becomes like a two-step process. The main issue I had with that was like just iterating over each of the build packs layers directory in a seamless manner through a final build pack. Like if we could solve that last issue where I could find each of the build pack layers and then at least even read that and write it to my own, like to that own build packs layers for exporting to environment variables, so like creating exec-d scripts, that would solve the same thing. But the main issue is iterating through all of these layers.
Kind of a spec violation right now.
Yeah,
you're not allowed to read or something.
that's why I was proposing this as like a new thing, because there's no way to do this right now, even with.
The way to do it right now might be to write a shim and wrap the build packs you want to use and then package it as a build pack. It's a little bit ugly though.
I mean, and I have to make sure that this shim is present on each build pack that's used. So I have to take existing build packs, modify the binaries that they have created, add that shim, repackage it, and then use it in my final operator image. I mean, this may be a very niche use case.
Is it that it needs to enrich those layers, add to them, mutate them, or is it adding more layers based, or is it adding more layers based on the contents of those layers?
I mean,
or both.
Either is fine. At the end of the day, I care about the behavior of the application and the metadata associated with the application.
So if the bomb contained not just information on what was contributed, but also on the build packs or the bomb or something like it, such that each build pack got information about previous build packs that had run, maybe a path to the layers that they've created, and metadata like that, would that then enable a totally separate build pack from executing against those? Like another operator provided build pack?
Yeah, I guess.
I guess what I'm trying to suss out is, it feels like maybe at the core of this is inter build pack communication challenges, which I mean, we definitely see that on many fronts.
If the layer from an earlier build pack is build equals false, you still want your build pack to be able to see it. So if the earlier build pack said, I don't want any build packs to be able to see this layer, you still want your build pack to be able to read it, right? That feels like it's fundamentally, sort of incompatible with the.
Well, what is, I mean,
You can
I
create
think a build,
coupling between build packs that is hard to untangle, right?
I think a build equals true more as like visibility in the sense of like putting the bin directory on the path and that kind of stuff. It doesn't mean that the files are not there and you can't read them.
That's supposed to mean. I thought.
Once a build pack starts reading the other files, you can create these complex dependencies from build packs that make them less modular, usable, right? That's why it's discouraged. Like, can we just contribute all these changes to the upstream build packs?
I guess the alternative could be like this shim or meta build pack could write in its own layers, but it executes after each build pack's build process has been executed. So if its launch equals true, it executes right after the build process, puts that stuff in its own common layer. Or like you can have like some shim layer so that these layers get exported out with that build pack that was set to launch equals true, and the next time it's built, if nothing changes, you don't have to read that information again or create changes to it. But again, this was very hypothetical, and I mean, it's not urgent. There are other ways to get around it. It's just convenient.
I think problem I can see is because build equals true is necessary to ensure that caching doesn't affect the availability of layers, right? Like if you set build equals false and launch equals true on a rebuild, that layer from the previous build pack may not exist at all, right? And so if you want to read that layer from a later build pack, even if it's an operator specified build pack, you're not going to be able to do it on every build, if that makes sense. There'd have to be something that tells the life cycle there's an operator specified build pack that's going to process this previous build pack's layer creation and then blow away the cache and then force the layer to get rebuilt, if that makes sense. If it's a launch equals true, cache equals false layer, for instance, right? Like it can't just reuse the one in the previous image because you need it locally for your operator controlled build pack. And so that'd be a big limitation also. If you really want to read a build equals false layer from that level, right? So even if you're just doing this in a hackish way or something, it would be hard to guarantee that all the layers you wanted were there every time.
But the layer toml gets restored, right?
Yes, with all the metadata according to layer content metadata.
And
change.
Yeah, and there was that RFC from Sam. So I'm wondering, like, do you need the contents in the layer, or can these build packs expose stuff? Like, I guess to Joe's point, like, is this solvable with better inter build pack communication?
I guess if it's something along the lines of compliance or making sure certain things are present in the final BOM based on the content of the layers, then you can't just do it from the layer toml. It depends on whether that build pack itself is exporting all of that metadata or not. You can't force that build pack to do X based on its contents. So
Yeah, you're saying you have zero trust in the build packs, the other build packs, right?
Or you assume that like these build packs. So there are two use cases. One, which is like build packs created by the operator themselves, which are completely trustable. And then ones which are created by users to get around their random build issues. And you want to ensure those latter series of build packs that they have provided are up to your standard. So it's not so much of an issue for like build packs that the operator themselves trust and wrote, but it's like when users get into the world of using their own build packs or like once you have something like inline buildpacks, how would an operator make sure that the final image that's created is still compliant? And it's
That
not
makes a lot of sense to me. You're like, I have this bomb that describes everything in my image. Also, you can write an inline build pack to do whatever you want. Those two things are kind of at odds with each other, right?
It sounds like this is a tool to scan images after they're built and then relabel them. And then, yeah, it changes the digest, maybe. But
it's not just digest, it's like also preventing things that could be potentially harmful.
but can't you do that after the image is built? And then, like, yes, you do have to have another validation step, but you can, like, you don't have to like pull the whole image and then push the whole image or something. You can just write extra labels into the config blob remotely if you wanted to. Like, you can do that. It's not that hard to do post-processing on an image after it's built. Are you sure that's not an option?
I guess, yeah, but then it also gets to the point where, like, let's say suddenly the API, the platform API, or the platform they're using, or the Buildpack API they're using changes. That's the same issue with all the image scanning tools and Buildpacks right now, right? Because the structure we use is so different. A lot of code scanning tools don't work, so you can't be sure that.
What if we added a final bin validate, or not bin validate, but final validator step in the lifecycle? And its job was just a platform can provide an unrelated, it's not a build pack or anything, validation script. And then it runs over all the files that were, generated there. And then if it's returns exit status 0, then it's allowed to conclude or something like that.
Let me give you an example. So let's say you have this inline buildpack that creates an environment variable, which is an override of a trusted buildpack that you have created. You want to make sure that doesn't happen. How do you prevent something like that?
Just allow inline build packs on your controlled platform.
Sorry?
Said disallow inline build packs on your controlled platform. That makes sense.
Yeah, I guess.
Wrap the inline build packs in a shim. Create something like pack file, which is just a thing that runs arbitrary things, but it validates them afterwards.
Yeah.
I want to point out we got 18 minutes left, and I know, Sam, I think you have some more things on the agenda also. Do you want to, is this helpful feedback to connect moving forward? Should we move on to the next agenda item, or do you want to stick on this one?
Yeah, sure. Should I just open this as a possible discussion with like the use cases, and so that we can do this offline? Okay.
That sounds
good. The detect stage limitations. It's again wait, I should put the link to the discussion, but it's the discussion that where is it? It was around like those, that case where you have 3 build packs involved in the process of contributing a dependency, which again, that also falls into that category of build pack communication, like inter build pack communication. I think I've tried to think a lot about this, and then the only clean way I have thought of is like adding an optional resolve stage that I said runs in the opposite direction of the build stage, which can make changes to the build plan.
in terms of the opposite direction of the build stage or opposite direction of the detect stage?
Opposite direction of the build stage.
So it goes backwards.
Yeah. So it starts from the lowest, like the. So if you had like a system build pack, a Go dist build pack, and a Go mod build pack, it will start from Go mod, then Go dist, and then the system build pack. So the Go mod build pack would make changes, the Go dist could make it, and then finally it would reach to the system, and if it wants to make something, then the build process will run the other way around to make sure that all of these changes are picked up. Um, it's roughly the same performance overhead as the current build step. Like you do the resolution in the build step. Instead, you could opt into having this extra resolve set that does the processing for you. And it has the same limitations. Like if you fail during build step because you can't resolve something, the same failures would happen if you can't, like you detected a group, but then during the resolution step, something failed. So it's again very similar to the build phase, but it just runs in the opposite direction so that it can communicate extra information.
The Buildpack API goes backwards during detect and forwards during build and backwards during
I mean, technically, detect is all done in parallel, right? So you don't have an order for detect. That's why I had to introduce this. If we are willing to give up that, that detect has to run in parallel and it can run things in any order, then you could solve it also during the detect stage.
I just meant the information flow, not the, but yeah.
I feel like we can't give that up because it would really slow everything down. And when things slow down, people get very upset.
But from what I can see, this is just moving the resolve step, which was already part of the build step, and build failures that can already happen to just a stage before it.
It's kind of like a defer, sort of.
Yes.
It runs in opposite order.
Yeah.
Builds can create a defer in your layer and then put a like an XID type thing in there, and then it, or not XID, but you know.
I mean, I wanted to change layers and things right before the thing actually. But yeah.
So like if the system build pack could defer some logic that could then install operating system packages after the rest of the build packs have run that they need, is that?
No, I wanted to install the right thing before all the other build packs run. I just wanted to know what the right thing to install is. That's the only responsibility of the resolution stage. I figures out what's the right thing to do with the layers.
So this runs in reverse order before the build stage.
Yes.
Okay, I see.
So let's say like that way your Go mod build pack could communicate to your Go disk build pack that, hey, I need Go 1.16. The Go disk build pack could then modify its build plan and send it to the system build pack. And then when it's running the build stage, it doesn't have to do resolution because it knows the right things to install. And you just resolved everything in one stage before that. And it will only run for the group that was detected. So I guess any changes you're making, any failures that happen there might also happen in the build stage, for example. So that was my reasoning behind having
Good
it.
idea. What if in the build plan, when you're requiring something, so let's say I'm the Go build pack and I'm requiring system packages, right? We have some way such that instead of saying the version of the Go system package I need is Go 116, because we have some syntax for saying like metadata from
Go mod build pack and substitute.
from yeah, like the from
I
like if I provide Go and I know someone could require it with metadata, a way to basically pipe the metadata from the requirer to the thing that I'm getting the next thing from, because then we could just do it all in detect.
Yeah, that's what I mean, you can do that technically right now, depending on how you implement your system build pack. You could have it resolve in a way that it can look at other, like the requirements and provisions from other build packs. First of all, I don't know if a build pack can look at metadata from build packs it doesn't, like for dependencies it doesn't provide. Can it look at the entire build plan, or is it given like a subset of it?
No. And I think even when you're saying this, you wouldn't be able to see who had required anything yet. All you could do is say like, I provide Go. This is admittedly probably horribly complex. Be like, I provide Go. And then when you're saying I require system packages, we can provide some syntax where you could say, by the way, the metadata from anyone who's requiring my provision, like feed it through here.
But I, I think it's just like figuring out how to resolve all of this metadata that's already present at the right time during the build phase.
Figuring out how to resolve it.
It's like
What
a
do you mean?
multi-step problem, right? It's like problem is that it's too flat sort of right now, that you can get stuff from requires into provides. But then if there are multiple levels of C makes a difference in how B works, which makes a difference in how A works, then you can't, there's only it's only one pass of resolution right now, right?
Yeah. But I'm wondering if as Buildpack B is sitting in the middle, instead of saying exactly what, instead of literally specifying the metadata in your require, if it could sort of be a reference so that the system could hook it all together for you.
Interesting.
So instead of metadata packages go 116, you could have a reference there that would refer to, the metadata I get from the person who requires Go, grab this key, put it here.
The only issue with that is this logic can get arbitrarily complex. And now the resolve logic in the build stage of the system build back will get arbitrarily complex. Like currently your Go disk build back knows of all the different ways you can, like all the different build packs that can specify a Go version and how to choose between one of them and solve any constraints that it has. Now it needs a way to specify all of those constraints in that reference way to the system build pack, and the system build pack now has to resolve all of this, and it needs to know that for each downstream build pack that uses it. So
It already has to understand the metadata of the downstream build packs that require things from it. And if by the time build starts, we've replaced all of those references with the real values, then nobody needs to be the wiser.
but I guess in that case you can only do a one-to-one substitute, right? So what if there are like multiple versions of Go that are being required by different build packs, and you have to choose between one of them? Which one do you choose?
That's an interesting question. I say we do the first one. And if you want something more complicated than that, then you're out of luck.
Yeah, if it's just the first one, then I guess you could do something.
I mean, we could give a syntax where you could say, square bracket 1, but I don't know how you'd really know that that's what you wanted.
Yeah.
Right? Like there already is that problem. If you get a bunch of conflicting requirements, you have to decide what to do.
But that resolution currently is limited to that one build pack that has the knowledge of all of these different things, right? But if you move to something like a system build pack, it has to know this for a bunch of different like build pack types.
That's why the build pack that's doing the piping picks. And we defaulted to the first one, so things are easy, but it could say, well, that'd be complicated syntax to put in a flat file, but something like that. I say we do the first one.
We got 6 minutes left. Do we want to keep talking about this thing? Not saying one way or another, but just, we have a couple other things left. Do we want to keep talking about this, or do we want to move on to the next thing?
I'm fine moving on to the next one. I guess like if you have more thoughts, it would be really nice if you can put it in that discussion. I'm just trying to figure out like what would be the good alternatives for solving this problem.
Before we jump into the next topic, can I just very quickly do mine, which will take 10 seconds. Part 2 of the user research share out is tomorrow during office hours. So please come to wrap up the discussion we had last week.
Awesome. All right, and so we'll jump to the next one, which is build right flag.
Yeah, I don't know what we want. So the alternatives were like have some common layers directory instead of being able to modify previous build packs. I guess those were the two alternatives that were prominent in the last meeting.
Even just
I
one.
make a suggestion that because this is a complicated topic that we're probably not going to get total resolution on in 5 minutes, could we maybe do the next one? Because there's some chance we could resolve that in 5 minutes and get it to a place where we could be merging it in soon.
Yeah, sure.
Well, it seems like there are some unresolved for the last kind of, 3 out of 4 of the ones Sim has open. There's some unresolved things. We're not going to have office hours tomorrow. Maybe it'd be good to schedule a follow-up discussion to kind of resolve some of those things. And if you have time, maybe it could be at a better time for you, time zone wise. Also, good.
Right.
Okay, so let's do that, and then let's move on to separating config from layers. 4 minutes, go.
Let me share this. I'm hoping that this will be uncontroversial because even if people don't like it, it's basically the only way to do it. All right. So let's say there's 2 build packs in one platform. We want to support new build pack API, old build pack API for both the new and old platform. For doing the new platform where we have the output directory, this is pretty simple. For the new build packs, we split into layers and config, just like we planned to. Old build packs can all be in one place. Everything's fine, I think. Any objections to that?
We're dropping support for once the build packs bump to the new build pack API, they're no longer able to have their metadata read in their build pack directory, but the build packs that are on the old build pack API will still be able to contribute files into their individual layers directory. The build packs on the old build pack API will not receive CNB BP configure and will have to continue to write files in their original
Yes.
locations.
From their perspective, nothing has changed. They don't need to know that we're making this change, and I think that is correct.
I'm fine with this, but want to point out that we could have infinite overlap in both directions for as long as we wanted and not break anybody, because there's no disadvantage to doing that for a longer period of time. I don't have an opinion. I just wanted to call that out. If that makes sense.
I think we try these days really hard never to change the behavior of old build pack APIs. So we're not going to give them new features. They got to upgrade if they want new anything.
Sounds good. Just wanted to call it out.
Philosophical hard stance. We're trying to change as little as humanly possible for old APIs.
Perfect.
But the first positional argument, and I guess like would you ever have both? Like you'd get one directory as the first positional argument, but then the environment variable would be set to something different?
No, for old build packs, the way we pass this in is a positional argument. For new build packs,
Yeah.
we don't pass the arg and you get the layer search. So for your new build pack,
Yeah, okay, that's what I was wondering.
Yeah.
We don't pass
Yep.
the arg. That's all I was checking out.
1 minute for the controversial part.
Controversial part. Okay, so if we're using the old platform API, we don't have an output dir. We're saying we don't change things for old APIs. So this has to be called layers and be set using CMB layers dir. And I think because we've actually specified in the API the literal paths to layer TOML. So like someone implemented their own exporter, it should work with the builder of the same platform API. We can't really change these paths for old platform APIs. So what we do is new build packs get their layers dir up here at the top level. And they get a config dir in a new place. Old build packs look exactly like they used to, but we're missing this intermediate dir for layers because it did not exist in the old platform API, and instead this was the layers dir.
Is there some disadvantage here? This just seems
No, it's
Like-
just ugly.
Why is
And the lifecycle team's gonna have to have a lot of conditional logic.
how's this uglier than the one before it?
Because these things are not at parallel levels. That's
Eh.
why it's unclear.
Seems okay to me.
I think that's just the way we do it. Like, I don't think that there's a great other solution. I think we just do this.
So this is just a transitional step, right? Like,
Yeah, but the transitional step will probably drag on for eons, at least for the Buildpack APIs. We should maybe start retiring some platform APIs at some point, because unlike the Buildpack APIs, people eventually upgrade those.
Are we confident that the advantages of doing it this way outweigh the effort involved in implementing it? So I remember people were like on the fence between this one and number 4.
Which one? The one we have in the proposal?
Yeah, the alternative 4, which is like essentially where we land anyway, with number 1.
In the compatibility case.
Yeah.
Yeah. I think the new one gives us more options to add other top level directories to structure things inside output. I guess we're past time here, but I think we need this compatibility logic. Also, last working group, I don't know if you captured this, Stephen, but you didn't like output and I want to be workspace. We're talking about moving the app in here. Maybe leave a comment about that.
Yeah, definitely don't like output there because it's not gonna make sense in the image once it gets generated. We can't change the paths.
That's all.
Thanks, everybody.